We shall be discussing the topic inventory model, and the aspects of inventory model we shall be discussing is to talk about the meaning of inventory. We shall look at the importance of inventory management. We shall consider inventory decisions. We shall consider the cost, inventory cost, the cost associated with inventory. We shall consider the economic order quantity, which is the same thing as the EOQ, and then we shall consider also quantity discounts, and finally we shall consider the other points. So these are the topics we shall consider under this topic. These are the aspects we shall consider under this topic, inventory model. Now, what is the meaning of inventory? Inventory are valuable resources that are not stored in form of cash, though they have cash value because they can be easily transformed or converted into cash. Every organization has one form of inventory or the other. For instance, manufacturing organizations have inventories in the form of raw materials, work in progress, and finished goods, while also commercial organizations have inventory in the form of finished goods that are waiting to be sold so that they can be converted to cash value. Inventory in any organization is known to form a large percentage or a large part of the monetary value of the total asset of any organization. So if you look at the total asset of any organization and you want to convert it to monetary value, inventory forms a large part of this total asset of any organization. So therefore, inventory has to be managed such that the cost of keeping inventory does not outweigh the benefit of keeping inventory. Now on to the importance of inventory management. The management of inventory helps the organization to achieve flexibility in the operations. It helps the organizations to achieve flexibility in their operations by providing what is called inflation hedge. Everybody knows that during the time of inflation, there is a general rise in the prices of goods and services. Therefore, keeping of stocks helps to provide a hedge, helps to provide an advantage for the organization such that if they still have stock, in their warehouse, if prices go up, they can go to the stock in their warehouse to avoid having to buy at a higher price. Also, another way that inventory management is important is such that demand and supply uncertainty is covered. We are not sure, we are uncertain about the quantity that will be demanded or the quantity that will be supplied. What if the organization asks the supplier for 1,000 units and the supplier is unable to provide that 1,000 units? Or what if the demand is like 5,000 units and the organization is unable to provide that 5,000 units? So therefore, the keeping of stock and the good management of stock will help to remove uncertainty about demand supply, because the consequence of the uncertainty about demand and supply is what we call stock out, and the stock out has cost implication. For example, the organization may lose the loyalty of their customers. Another very important reason why the management of inventory is very important is because of quantity discount. The supplier or the seller may offer the organization quantity discount, and then this quantity discount will lure the organization to buy more than usual in order to enjoy the advantage of the reduction in price that normally comes with quantity discount. So the organization wants to enjoy the advantage of the reduction in price that comes with quantity discount, and they are therefore forced to buy more quantity. This simply means that resources in form of money is now tied down. The resources of the organization in form of cash is tied down to this more quantities. So therefore, it is very important to manage inventory so that the resources of the organization are not unnecessarily tied down. Inventory decisions are made about the quantity to be ordered and when those quantities should be ordered. So inventory decisions are made based on two things. One is the quantity to be ordered, and two, the time to place the order. The quantity to be ordered is determined by the analysis of the economic order quantity, which we shall talk about much later. The quantity to be ordered is determined by the analysis of the economic order quantity. The time to place the order is determined by how long it will take between when the order is placed and when the order arrives. The time lag between when the order is placed and when the order actually is delivered is what determines the time to place the order. Inventory costs. These are the costs that are relevant in the determination of the appropriate quantity to be ordered. Inventory costs are the relevant costs in the process of determining the appropriate quantity to be ordered. And these costs are two. The first one is called the ordering cost of placing the order. The ordering cost is the cost of placing the order. And example of ordering costs may include telephone costs. The cost of telephone costs may include the cost of preparing payment voucher for suppliers, and then the cost of transporting the goods from the point of purchase to the warehouse may also be included in the ordering cost. The ordering cost is calculated as total ordering cost is calculated as the number of orders multiplied by the cost of order per unit, while the number of orders is determined by the annual demand, as the annual demand divided by the quantity ordered. The other part of inventory cost is called the holding or carrying cost. This is usually the cost of storage and dispensing of inventory item. Holding cost is usually the cost of storage and dispensing of inventory items. It is usually calculated as the average of the inventory items in storage, and it is usually priced in either in naira per unit or as a percentage of the purchase price. Therefore, the total holding cost is average of the quantity ordered average multiplied by the holding cost per unit, where the holding cost is either a percentage of the purchase price or cost per unit of item. Well, the main aim or the main objective of inventory model is to minimize inventory cost to the barest minimum. The main aim of inventory model or inventory management is to minimize inventory cost. So therefore, the best and the most appropriate quantity to order at any point in time is that quantity that gives you the minimum cost. The best and the most appropriate quantity to order at any point in time is that quantity that gives you the best or the minimum or the lowest cost. How do we now determine the best quantity to order? The simplest way to determine the best or the most appropriate quantity to order is by setting the inventory cost equal to each other. Remember that we discussed that the inventory costs are two. The inventory cost, which is the total ordering cost, and the total holding cost or carrying cost. So the best way to determine the appropriate quantity, which is the economic order quantity, is to set the total ordering cost to be equal to the total holding or carrying cost, and the total holding cost equals to the annual demand, which I shall represent by D, annual demand, divided by the economic order quantity, while the total holding cost is the economic order quantity, the average, multiplied by the holding cost per unit, and this is also multiplied by the carrying cost. So the best way to get the EOQ, or the economic order quantity, is to set the best way, the best quantity that will give you the minimum cost is to set these two costs to be equal to each other, in which case we have annual demand divided by EOQ multiplied by the cost of order per unit to be equal to the EOQ divided by 2 multiplied by holding cost. So if I cross multiply and multiply the left hand side, say multiply the left hand side by 2 and multiply the right hand side by EOQ. What I would then have is 2 multiplied by 2 DCO would to be equal to EOQ raised to power 2 HC. That's what I will have. So I've been able to eliminate this. 2 comes here. I'm able to eliminate this. This is multiplied by EOQ multiplied by 2. So I will have this. If I then take the square root, or I divide both sides, divide both sides by the holding cost per unit. So what I will have, it implies that I will have 2D into CO divided by HC will be equal to EOQ raised to power 2. This one goes off. So if I take the square root, of both sides, what I will then have is square root of 2 into DCO all over HC will be equal to the EOQ. Now this is how I am able to scientifically determine the most appropriate quantity to purchase that will give me the minimum cost that I require. Let's now take examples and see how this analysis of the economic order quantity is what will give us the minimum price. Let us assume that our annual demand has been determined to be 10,000 units, while the cost of placing an order has been determined to be 500. The purchase price has been determined to be 1,500, while the cost of storage or carrying cost or holding cost has been determined to be 30% of the purchase price. The best quantity, according to the economic order quantity analysis, the best quantity to purchase is the EOQ, which we have just determined to be 2DCO divided by. So if I put the figures, I have square root of 2 times 10,000 times 500 divided by 30% of 1,500. That gives me 2 times 10,000 times 500 divided by 450. So this will give me 10 million divided by 450, and that gives me the square root of 22222.22. And then if I find the square root, that will give me EOQ to be equal to 149 units. Now that we have determined our economic order quantity, which is the appropriate or the best quantity to purchase in order to minimize cost, to be 149 units, we can now determine the total cost, which is the total cost of order, or the total ordering cost plus the total carrying cost plus the total cost of demand. So the total ordering cost will be annual demand divided by economic order quantity multiplied by the ordering cost, which is 10,000 divided by 149 multiplied by 500, while the total carrying cost would be the economic order quantity, take the average multiplied by the carrying cost per unit. That's 149 divided by 2 multiplied by 450, while the total cost of demand is 10,000 units multiplied by 1,500 per unit. So the total ordering cost, which is annual demand divided by the economic order quantity multiplied by the ordering cost per unit, amounts to 33,557 whole numbers, while the total carrying cost or holding cost, which is the economic order quantity divided by 2, because it is carried per average, multiplied by the holding cost per unit, that's 149 divided by 2 times 450, that gives us 33,525, while the total cost of demand is 10,000 the number quantity demanded, that's quantity demand multiplied by the purchase price of 1,000, and that gives us 55 million. So therefore 15 million. So therefore the addition of all these three items gives us the total cost, which is 15,067,082. Now let us assume that a manager does not believe in this analysis, and the manager now decides that no, I will not take 149 units because I don't believe in this analysis. The manager may decide to take a quantity higher than this, let's say 200 units, or a quantity lower, let's say 120 units. Let's see how this will play out. So if this organization does not believe in our analysis and decides to take a quantity higher, which is 200 units, it means that the organization is taking quantity which is equal to 200 units. So therefore the total cost for that quantity, for that organization, as usual, is the total ordering cost plus the total carrying cost plus the total cost of demand. And the total ordering cost will be annual demand divided by the quantity multiplied by this, and that's 10,000 units divided by 200 multiplied by 500, while the total carrying cost will be quantity divided by 2 multiplied by the holding or carrying cost, which is 200 divided by 2 multiplied by 450, while the total cost of demand remains the same thing, 10,000 multiplied by 1,500. So from here we can see that our analysis with 200 units, has amounted to a figure that is higher than what we got using the economic order quantity of 149 units. We have arrived at what, 15,070,000 instead of the 15,067,000. Now let us also consider the situation where the organization buys 120 units. Let us see if the organization buys quantity 120 units. Our total ordering cost, as usual, will be annual demand, which is 10,000 divided by 120 multiplied by 500, while the total carrying cost is 120 divided by 2 multiplied by 450, while the total cost of demand remains 10,000 multiplied by 1,005. Well, we have also calculated using 120 units, and we have still gotten a total cost that is higher than what we got with 149 units. Let us now consider quantitative discount, which is a situation where the supplier or the seller gives the organization the opportunity to take advantage of a reduction in price if they buy a certain quantity that is higher than the economic order quantity. Let's assume in our previous example where our annual demand was 10,000 units, our purchase price was 1,500, our cost of ordering was 500 naira, and our holding cost was 30% of the purchase price, which amounted to 450 naira. And then we calculated our economic order quantity to be 149 units. Let's now assume that the supplier approaches the organizations and gives them the option, and gives them two options. The first option, that if they buy 1,000 units, they will get a 2% discount on the purchase price. That is, the first option of the discount is that if they buy 1,000 units, they will get a 2% discount on the purchase price. And if they buy up to 2,000 units, they will get 2.5% discount on the purchase price. So we have two scenarios now. The first scenario, where the organization has the option to take advantage of this discount and buy 1,000 units so that they can get a 2% reduction in the purchase price. Or the second scenario, which is to buy 2,000 units and get a 2.5% discount on the purchase price. Let's now demonstrate these two scenarios and see what will happen. So what is going to happen is that we will determine the difference in this individual cost that is brought about by the discount. First of all, for the purchase, total cost of demand will be, under the normal situation, 10,000 units multiplied by 1,500, and that gives us 15 million. Then if discount is given, we will have 10,000 units multiplied by 1,500 at 2% discount. It means that the buyer will pay 98%. The buyer will pay 98% of the cost price, which is 0.98 times 1,005. So the buyer will pay 10,000 multiplied by 1470. $14,700,000. So the organization would have saved 300,000. By taking advantage of this discount, the organization will save 300,000 from the total cost of demand. What about the total cost of ordering? Under normal circumstances, it will be annual demand divided by the EOQ multiplied by the cost of demand, cost of ordering cost. While under the discount, you have 10,000 divided by, the first scenario is 1,000 units multiplied by 500. This will give us 33,557, and this is 5,000. Subtract this, this will give us 28,557. So that the total savings will be 328,557. This is the total that the organization will save. Their cost will reduce by these two amounts. And then the holding cost, the total holding cost will be, under the normal circumstances, 149 divided by 2 times 450, and then 1,000 divided by 2 times 450. This is 33,525. This is 225,000. If we subtract this, have 191,475. So the organization will be able to make a savings of 137,000. The organization will be able to make a savings of 137,082 naira by taking advantage of this discount of 2%. Let's now see the scenario number 2, where the organization decides to attempt the discount of 2.5%. Let's now consider the situation where the organization decides to find whether 2.5% discount if they buy 2,000 units will be better than 2% discount if they buy 1,000 units. So the total cost of demand will be 10,000 under normal circumstances times 1,500, that's 15 million. While under the situation of discount, it will be 10,000 times 1,005 at 0.975, which is 2.5% discount. 975. Okay, if we take 2.5% discount of 1,005, what we have is 1,462.5, and if we multiply that by the annual demand, what you have is 14,625. So the organization makes a savings of 375,000 from the total cost of demand. Then from the total ordering cost, they will make 10 under normal circumstance should have been 10,000 divided by 149 times 500, and then under the situation of discounts with 10,000 divided by 2,000 times 500. This is 33,557. It's 2,500. This is 31,057. So the organization is able to make a reduction of 406,000 from these two costs. Let's now see by how much the total holding costs will increase, which is under normal circumstances 149 divided by 2 times 450, 2000 divided by 2 times 450. 3525. So they will be incurring expenses of 416, 475. So what this implies is that if the organization decides to take the discount of 2.5% buying 2,000 units, they will incur more expenses up to 10,418. So therefore, they will rather take the discount of 2% and buy 1,000 units, where they will be able to save cost. Finally, we shall consider the reorder point. The reorder point is the point at which order must be placed for additional stock. The reorder point is the point at which order must be placed for additional stock. To determine that point at which order must be placed for additional stock, we must be able to ascertain the time between when the order is placed and when the stock is actually delivered. The time between which the order is placed and when the order is actually delivered, that time is called the lead time. The difference between the time when the order is placed and when the goods is actually delivered, multiplied by either the daily or weekly usage. So let us assume that under our example where our demand is 10,000 units and the lead time takes 3 days. It takes 3 days between which order is placed and the goods that are ordered are delivered within 3 days. And then to know the daily usage, let's say we are using a calendar of 360 days per year. We are using a calendar of 360 days per year, or a calendar of 50 weeks per year, whichever one. So the reorder point will be the lead time multiplied by the daily usage. So in this case, the daily usage will be the demand divided by usage multiplied by the lead time. That's 10,000 units divided by 360 multiplied by 3 days. That will give us 83 units. So at the point where the stock is remaining 83 units, that's when another order will be placed for additional stock. Thank you very much for listening. I hope the lecture was worthwhile and enjoyable.